PUC 2 ಸೈನ್ಸ್ ವಿದ್ಯಾರ್ಥಿಗಳು ನಮಸ್ಕಾರ ಸ್ಥಿತಿಗೆ ಬನ್ನಿ. ಇಷ್ಟ ದೇವತೆಗೆ ಗುರು ಹಿರಿಯರಿಗೆ ಪ್ರಾರ್ಥನೆ ಸಲ್ಲಿಸಿ ಇಂದಿನೆಲ್ಲ ಅಭ್ಯಾಸಗಳನ್ನು ಏಕಾಗ್ರಚಿತ್ತದಿಂದ ಶಾಂತ ಮನಸ್ಸಿನಿಂದ ಮಾಡಿ ಮುಗಿಸುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಕಲಿತ ವಿಷಯಗಳನ್ನು ಜ್ಞಾಪಕದಲ್ಲಿಟ್ಟುಕೊಳ್ಳುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಜ್ಞಾಪಕದಲ್ಲಿರುವ ವಿಷಯಗಳನ್ನು ಪರೀಕ್ಷೆಯಲ್ಲಿ ಸರಿಯಾಗಿ ಬರೆಯುವ ಬುದ್ಧಿಶಕ್ತಿಯನ್ನು ಕೊಡಲು ಇಷ್ಟ ದೇವತೆಗೆ ಗುರು ಹಿರಿಯರಿಗೆ ಕುಲದೇವರಿಗೆ ಪ್ರಾರ್ಥನೆಯನ್ನು ಸಲ್ಲಿಸಿ. ಟೇಕ್ ಡೀಪ್ ಬ್ರೆತ್ಸ್. Yes, good morning, my dear students. In the previous class, we started learning the chapter solutions. This week, we are working on two chapters. One chapter in chemistry, that is solutions, and another chapter, important chapters, inverse trigonometric functions, or alternative days, right? Monday, today is Monday. We will continue with solutions, right? Alternate days, in between the gap, you have to make them perfect, solve assignments, send the doubts. I will also send assignments in the WhatsApp group. Join my WhatsApp group to get updates. Okay, let us continue with we have to learn about concentration. That is the first topic is measurements. We are learning measurements of matter, and we are talking about uncertainty in measurements in the previous class. Uncertainty in the measurement we have to study, right? Then in the second topic we will continue with that is concentration of the solution. Concentration of the solution, I think we started already. Uncertainty in measurement, we have to learn. There are few more things in it. We will continue learning today, then continue with the concentration. In the last class I told you that there are some important units of concentration. Means amount of the substance present in a given volume of the solution. Means this is concerned with the stoichiometry. Means there are some units of measurement like molarity, like molality, right? Like a mole fraction, commonly used in the laboratory, as well as mole fraction, and normality, formality, parts per million. Like this, some of the units are used to express the amount of the substance present in a given volume of the solution is called as concentration. And before that, there are few more things I left in the last class. Before I continue, I think I defined what is the meaning of concentration, what are the different units, and how they can be converted. Very, very important. That mathematical part we are to discuss. In uncertainty in the measurement, I think we discussed uncertainty in measurement. One thing is that we can express it in scientific notation. I think we discussed about scientific notation. How do you write scientific notation? Any real number can be expressed as capital N into 10 raised to n, right? Capital N is a number which lies between 1 to, it will be greater than 1 and less than 9. 1 to less than 10, sorry. 1 to greater than 9, 1 point, right, to 9 point. You can write. So that is called as scientific notation. About that in detail, we discussed in our previous live class. And the second thing is, kindly read whatever, join the WhatsApp group, right? In the status of Logji, I have kept the Logji channel, I have kept the Puc-Ii WhatsApp joining link. Welcome to you all. Welcome. Good morning, Deepthi. Okay, no problem. Due to heavy rain, so you did not make any hurry things. Therefore, I have created this channel. If your health is not good, if you cannot travel, you can sit at home and learn. If it is available for local Dharwad students, can come and sit here. Otherwise, you can sit at home and study. Therefore, your study under any circumstance, class under any circumstance should not be stopped. Okay, you can send your doubts, right? No problem. Therefore, I have created, I am using technology so that transportation problem will be there. Sometimes it will be raining, nobody is there to drop you and pick up. Health issues will be there. For under any circumstance, Puc-Ii classes should not stop. So therefore, I have made this arrangement. If it is possible, you come and sit in the live class. Here some 7-8 students can sit here, local Dharwad students. Others can learn at home, no problem. But what is important is learning, not reaching classroom. I am using technology for the same reason. Okay. Even parents will not be free. They have to travel and drop. That technical problem, transportation problem, the live stream will solve. But you will have the same this thing. The second thing is, another thing I forgot to explain you is, in the last class, is significant figures. Very important. Note down significant figures and approximations. And what is the difference between precision and accuracy? Precision and accuracy. That is very important in scientific, that is uncertainty in the measurement. Generally, why this uncertainty occurs, we'll try to understand so that we can complete this topic now. Uncertainty occurs because of two things. Uncertainty occurs because of two things. One thing is that the defects in the instrument, defect in the measuring instrument, Suppose that you are using burette, you are using pipette. One is, or even you are using any of the scientific devices. So the device may not be perfect, the reading may not be perfect, or this particular, suppose that you are using a balance to measure the mass of the substance, that equipment is not properly well arranged, well set. So because of that, you may have defects in the measuring instrument is one reason for uncertainty in the measurement. Second reason is skill of the person. Generally, to handle an equipment, the student, skill of the student to measure the physical quantity. You may do mistakes while measuring length by using scale. Your measurement may not be correct. Suppose that you want to draw a circle of 5 centimeter, exactly 5 centimeter how to take. Your compass may not be working properly, like in geometry. Similarly, in laboratory, the skill of the student in measurement. Suppose that you are using measurement. Generally, whenever you want to measure the volume of a liquid in measuring jar or in burette or in pipette, so there you may do mistakes without a good training of how to measure. Generally, whenever you measure, your eyes must be perfectly parallel to that particular burette. So that this is the burette. If you read it from above, it may show 1 millimeter less, measurement, or if you are below, it may show above. Therefore, this skill in the measurement is another factor. Because of these two factors, the values may be uncertain. To understand these things, what is the difference between precise measurement and accurate measurement, and also approximation, rounding off a number. So these are regularly used in both physics and chemistry. With a common chapter comes for both physics and chemistry. That is what is discussed in your syllabus. Let us see, what do you mean by significant figures? Significant figures. What is the significant figures? We will try to understand. Some questions may appear on significant figures. Significant figures are nothing but, we'll take one example. What is a significant figure? And there are some rules to decide the significant figures. So generally, whenever you measure one thing, there are two things. One is certain, another one is uncertain, right? For example, if I take the number here, 9.15. So that I take here 3.157, 2.163. Suppose this is the measurement, say in grams, you are measuring. Clear? So generally, there are some rules. What are significant figures? Means meaningful digits. It is the meaningful digits. Significant figures are meaningful digits with certainty, plus and along with, or plus the figures are digits. The figures are digits or digits which is estimated or uncertain. Plus, generally plus or minus one digit. Plus or minus one digit which is estimated or uncertain. That value may be estimated or rounded off or may be uncertain. For example, if you measure a mass of a substance as 9.15 grams, right? So here there are some rules of deciding significant figures. What is the first rule is, all non-zero digits are significant. All non-zero. I will go on giving you example first. Non-zero digits. You can note down, open your notebook. Have a habit of writing, jotting down the points whenever you study in the classroom, listen a lecture or study at your home. This habit you have with a pen and paper. I always tell students, science should be learnt with a pen plus paper or notebook. Don't read anything by using pillow and sofa. Don't sit on pillow and sofa. Sit in a separate place so that your body should be straight, and sit on a table and a chair, and don't change your place. Fix your study time and study place. Fix your study time. This is my study time, observation, and study place. This is my observation for many years. Like you will have a puja room, puja place fixed, no? Your dining hall, eating place will be fixed, no? Similarly, you have to fix your study time and study place. At that time only, sharp, if you sit regularly for 21 days, 3 weeks, you will get that habit. Or sleeping hours you fix, right? What is your sleeping hour you fix? So that is called as routine, right? Similarly, you fix your study time, study hours. At the same hour, you have to study the same subject, not with pillow and sofa. Don't change your place. These are some of my instructions I have been giving students for more than 27 years. Those students who follow my instructions have done well. And don't bring any person, any friend, brother, sisters at your study table. That group study is meaningless. That is done only in the supervision of a teacher. If there is a teacher in the classroom, he will look after, he or she will look after. You alone, if 2, 3 of you friends sit together, you 5 minutes, in 1 hour, you 5 minutes, you talk about subject, remaining 55 minutes, you start talking about other things. I know it. At your age, it is common. You are young students have this discipline. Whenever you attend a science class, whenever you attend a particular lecture, right? Don't talk with others in the classroom. Have focus on what the speaker is speaking. Jot down the important points. This habit is lost. Writing habit is decreased. Therefore, you are facing problems and you are listening. Listening is very important. And whatever you listen, it should go to permanent memory. For that, whatever you read, whatever you listen, you jot down your own notes. Prepare your own notes. That is the first step. Once your things are perfect, then first reading should be done very, very systematically. It may be slow depending upon your capacity. Why I am telling you, sit alone at your study room. Don't allow anybody, because different students will have different ability, speed. Suppose that you are very fast in mathematics, one of your friend is slow in mathematics. ಬಹಳ ಮಂದಿ ಏನು ತಿಳ್ಕೊತಾರ ಅಂದ್ರೆ ಅವ್ರಿಬ್ರು ಕೂಡ ಓದಿದ್ರೆ ಅವ್ರ ಜೊತೆಗೆ ನಮ್ಮ ಹುಡುಗನು ಇಂಪ್ರೂವ್ ಆಗ್ತಾನೆ, ಆಗೋದಿಲ್ರಿ, ಇಬ್ರು ಹಾಳಾಗ್ತಾರ. This is my fact. I have got results also. One student who were expecting as 95 plus got 86 because of this thing. That is one of his cousin who was poor in mathematics, and one of the student who is very good in mathematics. Both of them are out to sit by the family members. I request all parents, don't have this habit of bringing different capabilities. You may be fast in physics, some others may be fast in mathematics, some others may be fast in biology. Every child will have different potentials in different subjects. Therefore, in your capacity, right? Some students are trading once, they will become perfect. Some students need 3-4 times. Some students need 5 to 10 times. Slow learners will be there. All students do not have equal capacity because of their indisciplined lifestyle. Okay, have this discipline in your mind, and every day you sit at the same place. Take a pen and paper. Whether you teach, I'm a chalk and talk teacher and pen and paper teacher. But I'm using technology so that you can. Good morning, Sanju. Good morning, all of you. Okay, let us learn significant figures. All non-zero digits are significant. Observe here. So that I take a decimal number. The mass is measured in decimal places, 9.15 if it is the measurement. So here, these are all non-zero. Therefore, 1, 2, 3. How many significant figures in 9.15? 9.15 has got a significant figures is 3. You have to consider this dot also. 1, 2, 3 digits are there. Significant figures with the total significant figures are 3. The uncertainty, this last 5 digit is uncertainty. So which is uncertain is 1 digit. If I take for example 3.157 I have given here. How many significant figures are there? 1, 2, 3, 4 significant figures. Which one is uncertain? Uncertain is 7. Uncertainty in it will be 7. This is certain. 3 is certain. 3.15 is certain, and last digit will be uncertain. If you take 2.163, here how many digits are there? 4 digits are there. 4 significant figures are there, right? Last one is uncertain. How many of them is uncertain? 1 is uncertain. Last one will be generally uncertain. Means in them with certainty, significant figures with certainty. Here you can observe significant figures with certainty is 2. 9.1 is the definite. but 1 is uncertain. In the 3.157, 3.15, three digits are certain, 1 is uncertain. Total number of significant figures are 3 here. 3 plus 1 is 4 here. Here you can observe 2.163 with certainty, the significant figures with certainty is 3 plus last one is uncertain. Total number of significant figures are 4. I hope you understood the meaning of this law. Second one is zeros. Suppose that zeros to the right of the decimal number. Observe here 6.0, 6.00 or 4.50. If you observe 7.230, the rule tells that zeros to the right of the decimal, zeros to the right of decimal point are significant. 0 to the right of the decimal point are significant. Observe here, significant. The same 6, I can write it as 6.0. When I write it as 6.0, now the number of significant figures are 2. 6.0. How many significant figures are there? 2. Right? In that 1 is certain plus 0 is uncertain. Totally there are 2 significant figures. And if I write 6.00, in that 6.00, how many digits are there? Significant figures are there. So 2 are there with certainty and 1 is there uncertain. Total number of significant figures become 3. It has got 3 significant figures. And if you take a 4.50, right? How many significant figures are there totally in it? 3. Of them 2 are certain and 1 is uncertain. Totally become how many? 3. In case of 7.230, how many total number of significant figures are 4. Of them 3 is certain and 1 is uncertain. Totally 1 is uncertain, 0 is uncertain. Therefore, you can take total number of significant figures as 4. This is the second law. I hope you understood. Yes. What is the doubt? What is the doubt? Tell me. Yeah, while I will be explaining here, I cannot look at the chats. You join my WhatsApp group. Okay. Waste channel. Okay. It is your feeling. I have no doubt about it. You can ask the doubts. Generally not in the chat box. Even your WhatsApp group is there. You can send the doubts after joining. Okay. What is your doubt? Clear it. Ask the doubt question. Ask the doubt question. After writing one sentence, I will see. Okay. Yes, what is your doubt? Lucit Mupuri. It is not, if you feel it is waste channel, you can quit my channel. I have made WhatsApp group, there you can send after the class is over. Okay, I will be explaining you. Yes, you can clarify the doubts. What is certainty? What is the uncertainty? Second property you learnt. Third one, zeros between. Ask your doubt instead of doubt. You ask no. How can I understand what is the doubt? You write the doubt. I will see. I will come back and see. I will be writing on the board no at that time. Okay. I have to see in the WhatsApp, in my laptop, the doubts I will see, don't worry. Zeros between two non-zero digits. Non-zero digits. Zeros between two non-zero digits are significant. Ask the doubt. are significant. Means what is the number with certainty? Last one digit will be uncertain. Plus or minus one digit will be uncertain. Total number of significant figures are 4, right? Except the last one. First 3 are significant, last one is insignificant. Ask the doubt. 2 non-zero digits are significant. I hope you understood. Now I will give you the example. Observe here. 3.06 if I write 2.007. Observe here. In this 0 is in between 3 and 6. It is significant, means it should be considered with certainty. In that first 2 digits are certain and last one digit is uncertain. Therefore, total number of significant figures are 3. Observe here also. How many significant figures are there? 2.007. Totally, there are 4 significant figures. Total number of significant figures should be 4 only. Of them, except last one, how many digits are left? That is significant. That is certain. Plus 1 will be uncertain. Total number of significant figures become 4. I hope you got the point on significant figures. Any doubts in this? You can clarify the doubts now. Is that clear? Next, fourth rule in knowing the leading zero before the decimal point. The zeros before the decimal point. Before the decimal point are decimal point are not significant. Till you get the first non-zero digits. For example, if I write 0.518, how many significant figures are there? So this particular 0 before decimal point is taken as a significant figures are 3 only. Again, in that these two will be certain, one will be uncertain. It is understood henceforth. So that if I take 0.006, how many significant figures are there? So the zeros before the first non-zero, first which is the non-zero? This is 0. After decimal point, first place is 0, second place is 0, and the non-zero digit starts from 6 only. Therefore, the number of significant figures will be 1 here. I hope you got the answer, right? So 0.0618. How many significant figures are there? Zeros before the first non-zero. Zeros before the first non-zero, decimal point or any first non-zero. First non-zero means here you have to count 1, 2, 3. Therefore, significant figures are 3 here. Very simple, my dear students. You can understand it. Of them, last one will be uncertain, remaining will be certain. That is what is uncertainty? Plus or 1 digits should be uncertain. Next rule is when a number ends in zeros, when a number ends in zeros, when a number ends in zeros that are not to the right of the decimal point, ends in zeros that are not to the right of significant figures, to the ನಿಮಗೆ ಹೇಳಿಕತ್ತೀನಿ ನಾನು ಸೊಲ್ಯೂಷನ್ಸ್. Significant figures are not significant. Just I am refreshing you. Significant. So that if you take 160 centimeter, actually you learnt in first PU. I am just refreshing it. And if there is no decimal point, how many significant figures are there? 0, only 2. If you take 16500, only 3 significant figures. I hope you understood. You learned them in the 10th standard or first PU. Just I refreshed you how to decide the significant figures and the rules, and approximation also you learned. You can refresh it. Let us continue with the units of expressing concentration. You studied in the first PU, therefore I am refreshing you. Units of expressing concentration. In the solutions you are learning concentration. I told you what is molarity, what is first one will take what is molarity of expressing the solution. Coming back to the 12th standard, see, you studied in the 11th standard all of them. Clear? We will continue. Molarity. What is molarity? Molarity is the number of moles of a solute dissolved in 1 liter of solution. 1 liter of solution is called molarity. These are units of expressing concentration. Last class I was talking to about the concentration. Generally symbol used for molarity is capital M, and mathematically it is given by what do you mean by moles? You studied mathematically. One of the important thing is that molarity is equal to number of moles upon per dm cube. Generally we take mole per liter, right? So how to calculate mole? To calculate mole, you studied in the 11th standard. There are different ways of expressing mole. If the mass of the solute is given in weight, that is mass upon molecular weight. Mass divided by molecular weight gives you mole, right? And liter, 1 liter is equal to, you studied it as 1000 cc, or even the conversion, centimeter cube can be written as a 10 raised to minus 2 cube, because centimeter is 10 raised to minus 2 raised to 6. You get 10 raised to 3 into 10 raised to minus 6. You get this is equal to 10 raised to minus 2 meter. That is equal to 10 raised to minus 3 cubic meter. These conversions you remember. Then calculation of molarity becomes very easy. The first unit of expressing concentration of a solution is, maybe any solution, is molarity. What is molarity? There are different definitions for molarity. You studied in the 11th standard. I am just refreshing it again. Mole per liter. Mole can be obtained if mass is given upon molecular weight. I will take one example and try to clarify. Calculate. Take this problem. Calculate molarity of a when when 20 gram of sodium hydroxide is dissolved in 200 ml of solution. Generally, solution will be aqueous solution. Try to calculate. You studied already molarity. Yes. Calculate the molarity when a 200 gram of sodium hydroxide is dissolved in 200 ml of aqueous solution. You can take aqueous solution. How to calculate this? To measure the molarity, observe. What is our formula? Formula to calculate is mole per liter. You have to convert this numerator mole. That is the number of moles. First you calculate number of moles. Per liter is the unit of expressing molarity. Means the definition tells you that the number of moles of a solute dissolved in 1 liter of solution. Say number of moles. To get number of moles, you have to take W upon M for a simple symbol. W represents mass. What is the mass of the sodium hydroxide you have taken here? Is 20 upon molecular weight. What is the molecular weight of sodium hydroxide? How do you calculate molecular weight of sodium hydroxide? You must remember molecular weight of very important compound. You studied in the 11th standard. Atomic weight of sodium is 23 plus oxygen is 16 plus 1. What do you get here? 39 plus 1 is 40 grams divided by 40. 0, 0 cancels. 2 1s are, 2 2s are. There you get what? 1 by 2 m. Means, wait, 1 by 2 mole. You got a number of moles as mole. Now, you have to convert. 200 ml is given. But you have to write it in liter. What is 200 ml? Means that 1 ml is equal to, remember, is equal to 1 cc. Are you getting me? Then 1000 ml will be equal to what? 1 liter. Now we have to calculate it number of liters. What is the formula to calculate number of liters? Number of liters is obtained by, see, 1000 ml is equal to 1 liter. Then a 200 ml is equal to how many liter means? Yes, you can write 1000 ml in the denominator, right? And if you are given with x ml, here x is what? X is 200 ml. He may give 800 ml, 700 ml, whatever it may be. The x ml should be written in the numerator and 1000 ml in the denominator. And x ml is 200 ml. Means cc divided by 1000. Now it is converted to what? 0, 0 cancels. 2 upon 10 becomes 0.2 liter. And 1 by 2 can be written as 0.5 mole. I hope you are getting me. Now you go for calculation of the molarity. Molarity is given by number of moles divided by volume of the solution in liter. Simple formula. Number of moles upon volume of substance in liter. What is the number of moles of sodium hydroxide we calculated here? 0.5. Later we can speed up. Divided by 0.2. This point cancels. 2 1s are, 2 2s are 4, 2 5s are 10. You get what? 2.5. Capital M you can all write. Even you can write it as 2.5 mole per dm cube. What is the dm cube is? Dm cube is nothing but 1 dm cube is equal to 1 liter. Remember, you learnt in the conversion. If you want to learn all of them, you can see my first PU, some basic concepts in chemistry. Just I am refreshing you. Already you know this. That is 1 dm cube is always equal to 1 liter. Therefore, generally we express the molarity. Sometimes they will write it as number of mole per liter is also correct, or you can write mole per liter, or some authors will write it as mole per dm cube. Never get confused with the dm cube and liter. 1 mole per liter, unit of molarity, is m, is also correct. Mole per liter is also correct. Mole per dm cube is also correct. Right? I'll give another example on this. You try now. Open your book. Try this problem. 1.23 gram of sodium hydroxide. Take another example on calculation of molarity. 1.23 gram of sodium hydroxide is dissolved in water, and the solution, level 1 questions to start with, then we will take more complicated questions on it. This is the important area. 1.3 gram of sodium hydroxide is dissolved in water, and the solution is made up to 100 cc. Calculate molarity of the solution. Yes, try this problem. Take 1 or 2 minutes. Molarity. Yes, what is your answer? 1 point solution. So simple formula to calculate the molarity is N by L. Right? You can write the number of moles. Mass is given here. Mass is given. Correct as W upon M. And volume should be in liter. But it is given here as cc. Okay. Therefore, you can take it as 1 liter is equal to how many centimeter? 1 liter. First you get N, then you can express the cc in a liter. How do you express cc in liter? 100 cc you are taken here. That is x upon 1000. You can have the simplest formula, W divided by x into 1000 upon m. M means molecular weight, mole per liter or mole per dm cube. Try to substitute the values here. You can get, if the volume is given in cc, 1000 cc means 1 liter, x cc means how many liter? If 100 cc is given, this 100 is x here. What is the substance? Sodium hydroxide. Its molecular weight is 40. You can have this simple formula for fast calculation. Time saving result, you can directly write it as W upon, what is the mass of the sodium hydroxide? They have taken 1.23 grams. 1.23 grams divided by, what is x here? X is 100 cc into, you can take 1000 divided by, what is the molecular weight of sodium hydroxide? Is 40. Now you calculate. There are 2 zeros, 1 0, 1 0 calculated. Divide 123 by 4. You must be quick in calculations. Slowly go on improving. Therefore, molarity is given by, you are left with 1.23 divided by 4. How do you cancel it? 4 ones are 0.4, 3s are 12. Right? Is 3 divisible? No. 0. You can write 0. and now it becomes 30. How much you get? 4 sevens are 28. 4 8s are 32. Therefore, your answer will be 0.307. Same thing I was telling you. Approximate it. If the last uncertain digit is 7, then you add 1 to the previous one. That is, you can write as 0.31 molar. 0.31 molar. Are you getting the idea? Check your answer. Check your answer. Solve another one. 1.8 gram of, try another one, another problem on it. 8.1 gram of, try third example. 8.1 gram of glucose is dissolved. Glucose is dissolved in a 60 gram of water. Dissolved in water to form 300 ml of solution. 300 ml of solution. Calculate its molarity. First unit of measurement. Try this example. Right, try the solution. Take 1 or 2 minutes and tell me your answer. Those who are in a live stream. 8.1 gram of glucose. 8.1 gram of glucose. First of all, you have to get, that is molarity can be obtained by using, when volume is given in cc, mass, you must know what? Number of moles upon volume of the solution in liter. Calculate the number of moles if you cannot directly remember. And even I have given you shortcut also, that is W divided by X into 1000 divided by molarity. What is the mass given here? 8.1 gram. Take 8.1 gram here. What is the volume? Volume is 300 cc into 1000 divided by molecular weight of glucose. Glucose has the formula C6H12O6. Sometimes they will give, sometimes they may not give. You have to calculate it. If you calculate it, you will get what? 180. How? That is 12 into 6. Because atomic mass of carbon is 12. 12 6 are 12 into 1. Atomic mass of hydrogen is 1 plus 6 into 16. Your 12 6 are 72 plus 12 1s are 12 plus 16 6 are 96. You can get here 6 plus 2 8, 8 plus 2 10, carry 1, 9 plus 1 10, 10 plus 1 11, 11 plus 7 is 80. Therefore 180 grams. Gram molecular weight of glucose is 180. You can substitute the value. This is 180. Now you can calculate easily. Right? 2 zeros cancel, 0 cancels. Now divide 8.1 by 18. 8.1 by 18. You can write it as 81 upon 180. Now you start dividing by 180. Check, anything cancels. You can take it as 9 9s are 81. 9 2s are 80. 9 2s are 18. You can take 2 1s are 2 4s are 8, 2 5s are 2 4s are 8, 2 5s are 10. You get 4.5 divided by 10. And whenever number is divided by 10, you have to shift the decimal point to the left. So that is expressing it in the standard form, that is 0.45. mole per liter. Mole per liter. That is the calculation of molarity of a solution. And let us move on to the second unit. Later I will come to the more complicated questions. First of all, you try to understand the formulae required for calculation of molarity, molality, mole fraction, and parts per million. Second unit. Second unit is molality. There is a one letter difference in molarity and molality. See, just a difference. Molality is nothing but the number of moles of the solute, the number of moles of the solute, number of moles of solute, number of moles of solute dissolved in 1 kg of solvent. Look at here, 1 kg of solvent is called as molality. The symbol used for molality is small m. Look at the difference between molarity and molality. So molality is related to mass of the solvent. Very, very important. Mass of the solvent. Right? I will and the formula will be m is equal to number of moles per kg of the solvent, not solution. Note down the formula correctly. Number of moles, same. So in molarity, what is the molarity? Molarity is the number of moles upon volume of the solution in liter. It is mass of the solvent in kg. That is the main difference between the formula of molality and molarity. Right? I will take one example. Just now we solved. The same question I will give you. Take another example to calculate both molality as well as molarity. Important. Take this one. 1.8 grams. 1.8 grams of glucose is dissolved in 1.8 gram of the glucose is dissolved in 60 gram of water. See the mass, 60 gram of water. 60 gram of water. 60 gram of water. Calculate. Last problem today. Calculate. A, capital M, B, small m. Try this one. Try this one. Yes. First of all, let us calculate molarity. Look at here. To calculate molarity, what you need? Volume you need. But this time what they have given? 60 grams of water they have given. 60 grams of water they have given. Calculate. See, generally density of water is 1 gram per cc. Means what? In 1 gram there will be what? 1 cc of water. In 60 gram, what is the volume? 60 cc. Because the density of water is 1 gram per cc generally taken. Means 60 gram in 60 cc only, no problem now. In case of water, if it is a solvent, no problem. Both molarity and molality have no problems now. Now let me calculate molality. Is given by number of moles upon volume of solution in liter. Number of moles is another shortcut formula we collected. W upon X into 1000 upon Volume of the solution. Volume of the solution. Molecular weight of the solute. Just now we calculated molecular weight of the glucose as 180. Mass you can take. What is the mass here? Mass is 1.8. You can take volume of the water, volume of the solution. Means 60 gram of water will have the volume same because the density is 1 gram per cc. Therefore, you can take it as 60 ml. We will get here 1000 upon molecular weight is 180. Very simple question, my dear students. Cancel the decimal point, you will get 600. 18 ones are 18 tens are. There are 3 zeros, 2 plus 1, 2 plus 1. 3 zeros cancel. Right? Now you are left with the 18 upon 6. That is what is molarity. Molarity is given by yes, 18 upon 6. Yes, 18 upon 6 means what? 6 ones are 18 upon 6. 6 ones are 6 threes are. Therefore, molarity is a 3m. Are you getting me? Now, you try to calculate molality. Just now we collected the molality. So, molality is also same thing. Number of moles is obtained by mass upon molecular weight divided by, see, the mass is given in water. Mass is given in water. 60 grams of solvent. Water is given, not the solution. 60 gram of solvent, because mass in kg, observe here, 1000 gram is equal to what? 1 kg. Then x gram is equal to how many kg? You can get it as 1000 divided by x of the solvent. Remember, mass of the solvent, x is the mass of the solvent, right? Therefore, x of solvent, not solute, because the solution contains both solvent. If the solution is given, the question will be different, upon 1000. You can simplify and write again as a w upon m into denominator of 1000 goes to where? Numerator. Goes to numerator. Divided by mass of the solvent. Mass of the solvent is written here, x grams. Now you can simplify and write the question. You can take now, what is the mass of the solute? Mass of the solute is taken as 1.8 gram. 1.8 gram. Molecular weight is again 180. And 1000 divided by, what is the mass of the solvent? Mass of the solvent is 60 grams. Is mass of the solvent. Cancels. You will get here 1800, 18 ones are 100, 20, 20 cancels, 10, 10 cancels, you will get 1 by 6. 1 by 6. You will get here 0. 6 ones are 6, 40 you are left with 1 by 6. It becomes 10. 10 by 6. 6 ones are 6, 40 you are left, 6 6 are 36. Again you are getting 40 recurring. Therefore, answer is 0.166. You can round it off as 17 mole per kg of the solvent. Mole per kg. Generally, it is expressed in mole per kg. Molarity is expressed in mole per liter. Mole per liter. I hope you understood, my dear students, what is molarity and molarity. Next we will see few more units of concentration of measurement. Right? Tomorrow we will continue with the inverse trigonometric function. Till then, bye bye. See you.